8 by 6 memory.
You'd have to have more address lines.
How many of these cells would I have to have?
4.
I'd have to have 4 of them. Okay. How many address lines am I going to need to specify my 8 words? 3 of them. Yes? 2 to the third is what?
8.
Okay. Now I have to come and give you this idea, this chip select, and how we're going to use that. So before I do that, we need to talk about tri-state output.
Call for +1 4044372044.
Stop that. Trying to sell me insurance, I'm sure, or something. All right, tri-state output. How many output states have we talked about so far? 2. 0, 1, right? What's this idea of another state? Well, the third state is open circuit. So I could have a gate here . Okay, now you notice that my chip select line is just CS. So that means it ought to be what? Active high or low?
High.
High. So if I write a 1 here, and I put a 0 in here, what should I get out of this gate? A 1? It's a not
It's a
gate,
not
correct? Okay. 0 in, 1. If I put a 1 in, what do you suppose I ought to get out? 0. That sounds cool. Now I'm going to put a 1 in, but I'm going to take this guy and put a 0 there. This says, oh, go to your third state, and what's going to happen is that you open up the circuit there. Nothing comes out. Does that seem okay to you? Do you understand what's going on? It's just like you put an open circuit there. So you're taking this guy and you're just opening that. You got a switch there, nothing's going to happen. Why do you suppose that would be important? Well, let's take a look at one memory cell here. Well, let's Is what I just did good or bad? That's the answer I'm after. Next.
Good.
Why is it bad?
Because you don't have the gates to combine the two inputs.
Because why?
You don't have the gates that combine the two inputs.
You know, I've got two inputs. I got an A and a B.
Like the AND gates or the OR gates, you don't have one of those combined the two.
No, there's no and, there's no or. This
Exactly.
is what? Two not gates. And what did I do with them?
You wired them together.
Took the output and stuck them together, right? Yes? Okay. So would this be all right? 0, 0 in? Give us a 1 out, right? No big deal. How about if I did this? 1, 1.
That's still okay.
Yeah, that's okay.
But
Ooh,
That's-
what happens if I do that? What's the output? Not happy. You got one guy that's trying to write 5 volts to it, and you got the other one that's trying to put a short circuit out there. It's not going to happen. Right? So if I want this to work, I could say, okay, I'm going to put a chip select 1 and a chip select 2 here, and now I can say, okay, I'm going to tell you which gate has control of the output. One of them, I will say, okay, you are in your tri-state mode, open circuited, and so you're not going to interact with the output. Is that all right with everyone? Yeah? Okay. Okay. Well, why is this important? Okay, remember I asked you that what are we going to do if I want a 8x3 memory? Okay, and we're using these same chips over here as my made up 4x3. No way in the world are you ever going to find a 4x3 memory. But for the sake of illustrations, this will. So, because it's an 8x3, number of I/O lines,
6,
3. Number of address lines,
3.
3, because 2 to the third is 8.
3.
Well, here, I'm going to have my 4x3, my 4x3. What I want to do is I'm going to take these I/O lines so this is I/O 0, 1, 2. This is I/O 0, 1,